In my related rates problem, the center fielder catches a pop fly and attempts to throw at a girl tagging at third. When the center fielder releases the ball, she is 120 feet away from the plate, and she throws the ball at a speed of 90 feet per second, at an initial height of 5 feet and an initial angle of 12 degrees. You can create a function for the trajectory of the ball by plugging these values into a parametric function. When the center fielder releases the ball, the girl is 40 feet away from home plate, running at a speed of 22 feet per second. You can create a function of the distance the girl is away from home plate by setting the distance is equal to 40 minus the rate, which is 22 feet per second, times the time the girl has been running since the ball has been released. The first part of the problem to solve is how fast is the distance between the girl and the ball changing when the girl is 30 feet away from home plate. In order to solve this, you must solve for the derivative of the law of cosine. The law of cosine solves for the distance the girl is from the ball at any given time. In order to solve for this, you must figure out how far the ball is away from home plate when the girl is 30 feet away from home plate. In order to do this, you must solve for the time it takes the girl to run for the 10 feet. In order to do this, you take 10 and you divide it by 22, which comes out to a time of 0.4545 seconds. At this time, you can calculate how far the ball is away from home plate by taking the parametric function for the ball, subtracting 120 minus the x component, square that, and then you add the y component of the ball at that time squared. You then take the square root of those two added together, and that is the distance the ball is away from home plate, which is 80.6326 feet. Then you must find the rate of change that the ball is changing at that point, and you take the derivative of the distance function, and you get a rate of negative 86.7991 feet per second. Then you plug all of these values into the function of the derivative of the law of cosine to come out with a value of negative 15.9807 feet per second. The second part of the problem is to solve for the rate of change between the girl and the ball when the ball reaches home plate, and to determine if the girl is out or not at home. To do this, you must find the time it takes for the ball to reach home plate. You may do this easily by setting 120 equal to the x component of the parametric function for the ball's trajectory, which would be 120 is equal to 90 cosine of 12 degrees times time. To solve for the time it takes the ball to get to home plate, you would divide 120 by 90 the cosine of 12 degrees, which would come out to 1.3631 seconds. Now, to find the distance the girl is away from home plate after 1.3631 seconds, you would take 40 minus 22 times 1.3631 seconds. At this time, the girl is 10.0113 feet away from home plate. Now, to find the rate of change between the ball and the girl, you would plug these values into the function for the derivative of the law of cosine, and you would get the rate of change to be negative 22 feet per second. From this, you can derive that the girl is still running towards home plate and is therefore out because the ball beats her to home. This is a model of my problem. As you can see in here, there's a cutout arc, and you can push the ball along to create the trajectory that it would go to reach home plate. You can also move the girl forward to simulate her running towards home. And that is my related rates project.